All right, in this video lesson, we're going to be looking at how to predict products of a double displacement reaction. So just before we do that, I just want to remind us that a double displacement reaction is when we have a reactant that's like AB here, and our other reactant will be CD. And what happens is we're going to say AB plus CD. What happens is that they essentially switch partners, and A ends up with D, and C ends up with B. So D, B, that's not what I wanted. Okay, so it looks something like this. So double displacement, they basically switch partners. So solubility is a really important factor when we are looking at determining whether or not two compounds will actually undergo a double displacement reaction. We use the solubility to determine whether or not that solubility reaction, or whether or not that double displacement reaction is actually going to happen. Now, so in order to do this, we need to be able to use our solubility table. And because that solubility table tells us whether or not a substance is going to have a high solubility, which basically means that it's going to dissolve. So thinking about something like salt or sugar, we add that into water and it dissolves. Or if it's going to have a low solubility. And if it has a low solubility, it does not dissolve and it precipitates. And when it precipitates, it's a solid. Okay, so before we move forward in predicting our products in double displacement, let's just do a quick recap of our solubility. And so our first example, I'm going to go back here. We want to know, is potassium hydroxide soluble or insoluble? I like to use this solubility table because all you do is match up. We are looking for potassium and hydroxide. So we just go to where they meet up, and we see where they meet up is an S. And so our S means that it is soluble. So we can come over here and we can say that potassium hydroxide is soluble. And then our next substance is iron 3 sulfide. So we're going to find, I'm right here. We're going to find iron 3, which is right here, and sulfide, which is right here. Where they meet is an I. And so our I means insoluble. And insoluble really means that it forms a precipitate or it forms a solid. So that's kind of an important thing here. Soluble on the solubility table means it gets the subscript AQ, and insoluble on the solubility table means it gets the subscript S for form. All right, so now that we know how to use our solubility table, or we've reminded of that, let's look at double displacement reactions. So remember, I already kind of said this, but remember, the general form for our double displacement reaction is AB plus CD is going to make AD plus CB. So remember that the products, like when the reactants switch partners, the products still have to be ionic compounds. So one of them has to be the metal and one of them has to be the non-metal. Okay, so it's just, that's how you kind of know what the products are. So a double displacement reaction has to involve two ionic compounds as reactants. And it has to occur in solution or in an aqueous solution. And remember, aqueous is just a fancy word for water. So it has to occur in solution or dissolved in water. If you have two ionic compounds that are both dissolved in water, a double displacement reaction is likely to occur if there's the following situations. So one of them is that one of the products so one of the products has to be insoluble. The other option is one of the products is a gas. This is something that we probably will not come across in our course. Or we might come across it, but we won't use it. We won't see it very often. Now, when we're saying that one of the products is a precipitate, the other product needs to be soluble. So basically, for a double displacement reaction to happen, you need to have one insoluble product and one soluble product. Okay. Now, the other situation where we see double displacement reactions happening is if it's neutralization. Okay, and if you remember from grade 10, neutralization is when you react an acid with a base. We will deal mostly with neutralization reactions a little bit later in our course. So in order for a double displacement reaction to happen, one product has to be soluble and one product has to be insoluble. So I would probably write that down. It's basically the biggest rule for double displacement reactions. So to predict whether or not it's going to happen, you can do that by figuring out the solubility of the products. So we're going to use our solubility table to determine if a double displacement reaction will happen or not, and to help us predict our products. So in our first example, we have sodium chloride. Okay, so we have, sodium chloride, aqueous, is mixing with silver nitrate. So I'm going to write those down as my reactant, but I'm going to write them down as in their formulas because I want a chemical equation. So sodium chloride, using my nomenclature, is NaCl, and it's told us that it's aqueous, so we know that it's AQ. That's really important. And our other product is silver nitrate. So using our nomenclature, we know the formula for silver nitrate is AgNO3. And again, it tells us that it's aqueous. So we're going to write AQ. Okay. And now we need to figure out our products. So remember, double displacement, they switch partners. So sodium is going to become a partner with the nitrate. And so we're going to make sodium nitrate. And so we have to use our nomenclature rules to make sure we get our formula right. So our formula for sodium nitrate is NaNO3. And our second product is going to be the silver and the chlorine joining up together. So remember, they just switch partners. So we know what the compounds are going to be, but now you have to look at the solubility table to figure out if one of them is soluble and one of them is insoluble. So we're going to look at our solubility table for sodium nitrate. And our sodium nitrate lines up right here. Oh, I lost it. And so that is a soluble substance. So it gets the subscript. Oh, that's not where I want to go. It gets the subscript AQ. I'm just going to do those maybe in blue because we looked those up. And our second compound, silver chloride, we'll go back to our solubility table. And silver is here. Silver chloride is insoluble. So it gets the subscript S for solid. Okay. So then we just do a quick little check. Does this reaction meet our criteria? And our criteria is that it has two aqueous reactants. So they're both AQ, so it meets that criteria. And one soluble product, which we have with this sodium nitrate, and one insoluble product, which we have as a silver chloride. So this reaction is going to happen. Check. It's good. Okay, so we're good. Let's look at our next example, barium chloride and silver chloride. Actually, I'm going to change this one. We are going to change this one. I've got a mistake here. We're going to change this one to sodium sulfate, NaSO4. So the first thing you want to do is do the little switcheroo and figure out what the compounds are that are going to form as your products. I'm going to rewrite out our equation. So I'm going to write out barium chloride, BaCl2, AQ, plus sodium NaSO4, AQ. Remember, basically our metals are just going to switch partners. So our sodium is going to become a partner with chlorine. And our barium is going to become partners with sulfate. Remember, you have to do the crisscross to get your proper formula. So if we do a crisscross, we're going to get barium sulfate is BaSO4. And then we have to check our solubility. So we're going to look for the solubility of sodium chloride. I'm going to do those in green. So sodium and chlorine is an S. So it's going to get a Q for soluble. And barium sulfate, here's our barium coming all the way over to sulfate. It is an I right here. So it is insoluble. So it gets an S for solid. Okay. You also want to just do, you should do a quick check. I got sodium sulfate formula wrong. This is Na2. Okay. If we were going to balance our equation to make sure this equation was balanced, there should be a 2 here. And then I think everything is happy. All right, now I'm going to completely change our last example. I'm going to scratch this one out, and we're going to do 2 different ones. Okay, so for this example, what I would like you to do, we're going to do NaBr aqueous plus calcium chloride aqueous. So I want you to hit pause, and I want you to So if you've done your crisscross properly, this one's pretty easy. The sodium and the chlorine are going to hook up, and the calcium and the bromine are going to hook up. So now you have to go to your solubility table and get your subscript. So I want you to hit pause and try that on your own. All right, so the solubility table is telling us that both sodium chloride and calcium bromide are aqueous. What this means is that this reaction doesn't meet the criteria for a double displacement reaction. So actually, the problem, what we write is that instead of writing our reactants these chemical compounds with their aqueous subscripts, what would happen is we actually are going to write no reaction. Because if we mixed sodium bromide and calcium chloride together, we would not get a precipitate. We would not see anything form because both products are soluble. So this is an example where a reaction does not actually happen because it does not make a compound that is a precipitate. Okay, so that's the end of looking at predicting products and whether or not we would get a double displacement reaction to happen. Remember, the biggest learning for this is up here in red. One product has to be insoluble and the other product must be soluble in order for a double displacement reaction to happen. Okay, so that's it.